Let's now look at the liquid-liquid extraction of a blood sample for toxicological analyses. First, what we're going to do is prepare a workspace by having the blood sample. We're also going to have a test tube holder or test tube rack and our labelled test tubes. What you will see here on the left-hand side is the appropriately labelled blood sample which has been collected from an individual. Has the name, the time of collection, date of birth, and the site from which the samples were collected, which in this case is the femoral vessels. What you will also find on there is a unique identifying number, which in this case is 1234. You will also see that the test tube on the front is labelled F blood and the unique identifying number 1234, and the two test tubes in the back are labelled acidic neutral and basic, again with the unique identifier 1234. Now what you will see here is that first and foremost we must check the sample details to make sure that they meet up with the paperwork that we have for the sample. We'll also just again check and show that we have the test tubes are adequately labelled with the appropriate samples, extractions and the number. Now first what we're going to do is we're going to pipette a portion of the blood sample into the test tube labelled F blood with the number 1234. Now for the actual volumes that will be dispensed for this whole practical, they are available in your script for this class and will be found on your site for this module. Now what you will see is that we are now dispensing using a Gilson pipette 1000 microlitres or 1 milliliter of the blood sample from the universal container into the test tube labelled F blood. Now do take care with the sample and make sure that you dispose of the tip into an appropriate container for biohazard waste. Replace the lid on the sample and set it aside and move to the next step. Now first and foremost what we are going to do in this case is to add an internal standard. Now what we are using here is a compound called proadophen. This compound is amphoteric, which means it can act like a base and act like an acid. What we are going to do is we are going to add this internal standard to the blood sample, and what should happen is it should be extracted into both of the layers that we will have for subsequent analysis. Now we will discuss internal standards and their use at a later date, but for now what we are using here is the proadophen, and we should be able to see it in both of the extractions when we carry out our analysis. Now first and foremost what we are going to do is to carry out our acidic and neutral extraction, and we are using 0.025 moles per litre hydrochloric acid. Again, for the appropriate and the volumes that had been used in this, please again check your lab script. So we are dispensing a small amount from the larger container into a beaker, which makes it easier to use, and also means that if we use the Gilson that we are not contaminating a whole bottle of our solvents or our acids and bases. So we have a small amount, make sure it's in labelled glassware, and we're going to use this to add to our blood sample. So by adding the hydrochloric acid to the blood sample, what we are doing is acidifying the blood sample. What that means is that any compounds that are acidic or neutral will now be extracted using ether, and we will be able to extract out any acidic stroke neutral compounds by adding this hydrochloric acid. So we've added the hydrochloric acid, we've disposed of the tip, and what we are now going to do is to set those aside and to now add our diethyl ether. Now what you will see here is diethyl ether, which is contained in the fume hood and has a dispenser on top. Now you will see in this instance it is set to 5 millilitres. So we are going to add the 5 millilitres of the diethyl ether to our acidified blood. Now we should always cap this before removing it from the fume hood because you do not want to have any of the fumes unnecessarily in the lab space. We will then move this over and we will take the blood sample and we will add it to our rotary mixer. Now please make sure that the lid is tightly in place and that you make sure that that test tube is also in place. Switch it on and you will see that we will leave it typically for about 10-15 minutes to rotate and to mix. So what happens here is any of the acidified compounds or neutral compounds will find themselves having a higher affinity for the organic or the ether layer rather than the blood, and so the ether should extract any of these samples. Now when this is finished, what we are going to do is to remove this and we are going to centrifuge it. Now the reason that we are centrifuging the sample is if you have a look at the blood sample that has the ether in it, you will see that there's quite a bit of mixing and there is no two distinct layers. So we'll place it into the centrifuge. We will then also find ourselves a test tube of water which has approximately the same amount or same volume of liquid as is found in your test tube with the sample. And the reason that we do that is to make sure that our centrifuge is balanced. You will also note that I'm counting 6 spaces, so again that the samples are opposite each other and again that the centrifuge is balanced. What you will see here is that I am checking the revolutions or the speed at which the centrifuge is going and the time that I would like it to be set for. Now once we've done that, we will press the start button and we will wait for 3 minutes in this case. So what you will see is once our centrifuge has come to a complete stop, we will remove our sample from the centrifuge. What you should be able to see in this instance is that the sample from the blood with the extract should have 2 distinct layers, one with the clear ether on the top and the blood on the bottom. And what should have happened is that any acidic or neutral compounds should be extracted into that top ether layer. And what we are going to do is to remove that top ether layer and we are going to collect it in the appropriately labelled test tube for acidic neutral. Now, what we would do in this instance is to make sure that we have the test tube labelled acidic neutral and we will transfer the diethyl ether layer into this test tube using a Pasteur pipette. Now in this instance it is best to make sure that we leave a small amount of the diethyl ether above the blood because we do not want to have any of that blood portion in the nice clean labelled test tube. We only want the ether layer. So carefully dispense or transfer the ether layer into the clean labelled test tube and avoid removing any of the blood layer. With this last portion, just be very careful not to suck up any of the blood and just to leave a small amount of the diethyl ether layer. Now what we're going to do is we are going to set aside that acidic neutral layer, we're going to cap it, and we are now going to prepare the blood for the basic extraction. Again, what we were going to make sure is that diethyl ether layer is capped. We don't want any loss of the sample, and we also don't want to have too much diethyl ether in the air in the open lab space. So, when we have done our acid extraction, we are now going to do our basic extraction using a 3% weight by volume of sodium hydroxide solution. Again, we will be dispensing a smaller amount, of the sodium hydroxide into a smaller beaker, again to limit any potential contamination, and also to make it easier for us to dispense using a Gilson pipette. So you can see that we're showing you an appropriately labelled glassware. Again, just because one clear colourless solution looks the same as the other, and so we want to make sure that what we have and what we are using is what we should be using. So a very small amount of the sodium hydroxide is transferred into the beaker. We're then going to dispense with our Gilson pipette and a required volume of the sodium hydroxide into the exact same blood sample that we have already extracted the acidic neutral compounds from. So you will see here that we're making sure that it's still the same femoral blood sample labelled with the number 1234. I'm also dispensing or transferring a volume of the sodium hydroxide with a Gilson pipette into the blood sample. Again, please check your script for the lab as to the required volumes of the hydrochloric acid and the sodium hydroxide. Now, once we have done that, what we're going to do is the exact same step that we did with the acidic neutral layer, and we are going to add the 5 millilitres of the diethyl ether layer, as we did with the acidic neutral extraction. One thing to note is that with the basic extraction, you will note a distinct colour change in the blood sample. So with the acidic layer, you will note that it was still a reddish colour, but by the addition of the sodium hydroxide, you will see that it is now a sort of brown greenish colour. However, same principles apply. Make sure the lid is on properly and make sure that you've secured that test tube on the rotary mixer before leaving. Again, this will stay on the rotary mixer for approximately 10 minutes, and then we will transfer it, as we did with the previous sample, into the centrifuge. Again, it will go through the same process of 2000 revolutions per minute for 3 minutes. Again, we will make sure that the sample is balanced in the centrifuge with the water. And again, we're checking the number of spaces in between to make sure that they are equal. So, when our sample is finished with the centrifuge, you will see again that you'll have two distinct layers. One is the ether layer on the top, which should contain any basic extracted compounds from the blood sample, and also the blood that is left on the bottom. And then we will remove our water sample, which has been obviously used for balancing. Now, exactly the same principle applies. We're going to remove the diethyl ether layer into our basic labelled test tube with the same code on there of 1234, and again we're going to take the same care with our passive pipette as we did in the previous sample. Again, please leave a small volume of the diethyl ether layer rather than attempt to get so close to it that you're going to draw up some of the blood. We do not want any of the blood component in the new test tube, so only transfer the diethyl ether layer. Now what we've got here is a sample concentrator, and you will see here that we've got two little spikes that have come from the top. They allow nitrogen gas to pass through the little spikes and down into the test tube. The bottom part is heated, so the test tubes are in a heater, which in this case is set to 50 degrees C. So we've placed our test tubes into the sample concentrator. We will remove the lids from the test tubes, and we will make sure that as we lower the lid, that the spikes where nitrogen gas is passing through them go straight down into the test tube. Now, please make sure that the little spikes are actually inside the test tube. You will see here that one is just hitting the rim of the tube, and if I just push it over slightly, the nitrogen will now be going down through the tube. Now, one of the reasons we do this, obviously we've got a drying gas over the top there, but also it can reduce any thermal degradation with oxygen in the atmosphere, and so this is what we want to do in this case. Now you will see here that we have the two layers have been, all the ether has been evaporated from the two samples. What we want to do now is to take these, and we are going to reconstitute them with a small volume of ethyl acetate. Now the reason we're using ethyl acetate is we're going to carry out this analysis by gas chromatography, mass spectrometry, and ethyl acetate is an appropriate solvent for this. So what we're going to do is we're going to add a very small volume, in this case a few hundred microliters of ethyl acetate into each test tube, and then we're going to pop it onto the vortex mixer just to make sure that any residue from the extract that's now in the test tube dissolves into the ethyl acetate. Now you'll see here, making sure that the ethyl acetate is added to both tubes and capped fairly quickly. Again, with such a small volume, you do not want it to evaporate at room temperature, because obviously this can affect your sample and what's detected. So you will see that now the both of them have capped. Replace the lid of the ethyl acetate, again to avoid the over solvent accumulation in the open lab. We'll pop on the vortex mixer, and just a couple of seconds to make sure that any of the residue that's left on the bottom of each test tube is dissolved into the ethyl acetate. Now once we have done that, what we're going to do is we're going to transfer the small volume of the ethyl acetate with the acidic neutral components in one and the basic components in the other. Now, what you will see here are two GCMS vials, again appropriately labelled with the acidic neutral and the code that is for that sample, and again here it's 1234, and it also has my initials on there. What I'm doing is I'm adding a small glass insert, and the reason that I'm doing this is because we have a small volume, and sometimes if there's such a small volume in the bottom of a larger vial, the needle will not go down far enough to pick it up. So we just add this small glass insert to make sure that the needle can pick up the sample appropriately. So let's see here, what we've got here is obviously our vials for the GCMS. Let's make sure that they are capped properly so that we don't lose any, and also make sure that they are capped so that the instrument can pick them up properly. If the cap is not on properly, it can stop the instrument because obviously it hasn't connected properly. Now again, we've put in the small glass insert. We're using our Pasteur pipette to transfer the basic extraction into the GC vial, and again obviously we're doing exactly the same thing because of the small volume. Again, we will make sure that it's appropriately capped, and both of these samples are now ready for analysis by GCMS.